In this video, I will introduce the idea of an operating system. An operating system is a set of programs that provides services to your program. Hello, I'm Bob Kummerfeld, and this is another CS tutorial. If you've been watching this sequence of videos, you'll have seen how we can represent numbers and characters and instructions as a sequence of binary digits or bits. You'll also know now how the computer, the CPU of the computer, interprets the bits of an instruction to carry out some operation. And in the most recent video, I've talked about the architecture, the instruction set of the computer, how it has things we call registers inside the CPU, how it talks to the memory and to the input-output devices, and how the CPU interprets those instruction bit patterns to do some operations on the registers and make things happen, actually make your program work. In this video, I'll move up from simple programs like that to the idea of an operating system. Now, the operating system is a large program, a very complex program, that provides services for your programs. Now, a simple system consists of just the memory and the CPU and input-output devices, and is what you'll meet in some other courses where you just have the bare computer, say a microcontroller, and you write programs that interact with I/O devices, but don't have attached to the machine a file system. They don't have any user interface. Typically these are for things like control applications. Simply in that case, programs are stored in the memory of the computer, executed by the CPU, and they access sensors and other devices like that. Now, of course, systems like Windows or the Mac OS provide far more than just the bare computer. They provide things like a very sophisticated graphical user interface, I/O devices such as keyboard and mouse. They provide mass storage and in particular a file system, and they provide network connections. They also allow multiple programs to run at once. Well, it seems to be running at once. Sometimes it's just simply swapping between them very quickly, but it's called concurrency. And many other services such as security provided on those systems. Now, this is what we call an operating system. And all these services, all these device handlers and so on are provided by this thing called the operating system. Now, many years ago, back in 1969, at Bell Laboratories in the USA, the Unix operating system was developed by Dennis Ritchie and Ken Thompson. There were many others that contributed, but Ritchie and Thompson are the main inventors of Unix. This was released to universities in source code form in 1975, and this is an operating system which we now use as the basis for many other operating systems. Many versions of the original and many clones, such as Linux, which you've probably heard of, have been produced since those days. But all are recognizable as a Unix-based system. We're going to use Linux for all our examples and all our lab exercises. Linux is a clone of the Unix system, and it was developed by a Finnish programmer called Linus Torvalds, and it's now been used as the basis for many other systems. For example, the Android system that you find on mobile phones, underneath that is running the Linux operating system. Unix is also the basis for all the Apple operating systems. So Mac OS, iOS on your phone, iPad OS, Watch OS, and so on all use a variant of Unix as their basis. So an operating system is a special program that is privileged, meaning you can access and control all of the hardware and carry out many of the basic services, such as the graphical user interface. So handling the mouse, handling the screen, and drawing things on the screen, the windows, all the different fonts and other graphics, web browsers and so on. The operating system provides services to these application programs. Sometimes there are application programs that also provide services to the user. Now, the major difference between an operating system and user applications is that there is a distinction between the operating system and user programs. Usually the CPU has two modes of operation, system mode and user mode. With these two modes of operation, user mode and system mode, the system needs to switch from user mode to system mode when an application requests a service, such as reading a file. To do this, there is actually a special CPU instruction. This is called a system call, and what it does is it causes execution to continue in the operating system in this separate system mode. So you've basically got the two modes, user mode and system mode, and you switch between them with a system call, which is a little bit like a function call, except it changes the mode of operation. When the system is in system mode, it has a lot more privilege. It can access certain hardware devices, access certain features of the CPU to do with security, access memory, a larger part of the memory, and so on. One of the services that the operating system provides is the file system. And the file system came about because disk storage and other mass storage doesn't impose any particular structure on your data and can be quite inconvenient to use. Persistent data is the sort of data that doesn't disappear when we turn the computer off. If you store information in the main memory, when you turn the computer off, the main memory, since it's powered, gets switched off, and in general it disappears. Now, there are types of storage that we can use for main memory that doesn't disappear, but the usual memory, the fast memory used in a normal computer system, will disappear when you turn the power off. So this means we have to store things on a separate device, such as a disk drive or some other mass storage device. Now, disk drives, we call them disk drives because that's what they used to be. They used to be rotating disks with a magnetic coating. They're implemented with various technologies now. Some of them are so-called solid-state disks, but they all provide persistent storage. In other words, storage that doesn't disappear when you turn off the power. The raw storage provided by these storage devices is not very convenient to use. It's just basically a great big array of bytes. And to make it more useful, we usually break it up and structure it into files and the files further into directories. And we call this structure the file system. The file system in Unix consists of a set of directories, or sometimes called folders, that can contain files or subdirectories. So if you look at this picture, we've got at the top level, we've got a directory myfiles, and inside that you might have assignment1.doc, notes.txt, other files, and then another directory, say for info 1112. And inside that we have another file, lecture1.pdf. And so this is a data structure which is stored on our mass storage, this folder and file structure. And at the lowest level, the files are data that's kept on the persistent storage. So we can look at that in many ways. For example, we could draw it like this. So with the top level, my files, then the next level down, and directories have files below them. Or we could draw it like this on the side. And we call this a tree data structure with the, in this case, my files, the directory on the left there, is at the root of this tree data structure. Now, all these names of directories and file names in the file system are often called the namespace. And I'd like to use that name in this course to refer to names in the file system as the namespace. It's the data structure that tells us where to find a file, in which folder, and in which subfolder, and the actual name of the file. And the reason we call it a namespace and not a file system is that we can put other things in the namespace besides files that hold bytes. As you'll see later, there are some names in the namespace which actually refer to devices. And when you write to one of these things, instead of writing to a file stored on the mass storage, it actually writes to a device, and vice versa. You can also have names in the namespace that refer to services. And so reading and writing to one of these names will invoke the service and give you information back or accept information. Another way of writing down where your file is in the file space is something called a path name. And in all Unix systems, we write it in the following way. So lecture1.pdf here is within a folder called info1112, which is within a folder called myfiles. And we separate these with a slash. Now this is just the written way of writing down this point in the namespace. And as I said, it's called a path name. And path names are very important because we're going to refer to all our files this way, and we're going to manipulate path names and move around in the namespace using the path name, using the path. Now, the bottom level here, or the root of the file system, is at the far left, and the root of the file system can be referred to with the single character slash. And within that, because that's simply a directory, we have subdirectories or files for that matter, and in this case, the first one at the root directory is myfiles. And so we can just give the name slash to indicate the beginning of our file system. It's the path that begins at the start of the file system. So there it is. It's a sort of a hidden name, if you like. This picture of the file system has all the names of the directories and the files, but there is one at the very bottom there which we would, in a picture like this, would not normally write, and that's the slash, or the root of the name system. Now, there's a lot more to say about operating systems and file systems. The kernel of the operating system is the program that runs to provide many services. It's supplemented with other programs, for example, the window manager to manage your mouse and to handle the windows and so on in your graphical user interface. The kernel of the operating system is also divided into modules that handle different devices and different file systems or different parts of the namespace and networking. Sometimes these modules are called drivers. And finally, there are other higher level application programs that provide services in your system, such as email or word processing, Microsoft Word, or an email program, Outlook, and so on.